Hey, what's up, guys? Okay, so today I want to prove a very simple principle that it's very simple. Maybe I don't need to prove, but you can think a little bit. But I will still prove. Hope you guys subscribe to my channel. Okay, so I want to talk about this idea called the random sum principle. And okay, so the settings that let's say I consider the f2 to the n. So basically, it's the field with only two variable. Basically, it's 0, 1 to the n. Okay, then I consider that I take two x, y belongs to f2 to n, then I can define a bit or sum, big X or sum. Should be just the summation of xi, yi, mod 2. Or simply speaking, that I can just write inner products, right? I could just xy inner product in f2. Okay, and so theorem, if I take the all the non-zero y, or if I take any y which is non-zero, it's not all zero, and I randomly choose x belongs to 0 and 1 to the n, and the probability of xy equals to 1, what is this? Half. So this is the theorem. Okay, so given any non-zero y, right, and I randomly choose a vector such that this vector inner product with this is 1, it's half. Okay. Well, this is trivial that it's trivial if you maybe you think a little bit, you can prove it by yourself. You can prove it by yourself, right? Let's say y is 1. Okay, I choose only one variable, so I just ask what is probability of x. Uh, yeah, this is trivial, right? Because this become xy, right? But I ask probability, so I choose x either 0 or 1. So this is probability of x either 0 or 1. X equals to 1, basically half. Okay, so it's trivial for the first one. Okay, so the you can think a little bit, but the proof is very simple. You think a little bit, right? You let's say so consider is some. If yi is 0, then I don't care, right? If y is 0, then don't care. It doesn't contribute to this number. Okay, so I only need to worry about I only need to worry yj is 0, right? For some non-zero for some j. Okay, then this sum, right, can be computed just by just xi, yi, where I differ from j, plus, because yj is non-zero, right? It must be xj. Okay, and let's say this is called c plus xj. C is either 0 or 1. Okay, so which means the probability of xy equals to 1 if I choose x belongs to 0, 1 to n. Basically, right, can be viewed as I just pick j. I can just ask what's O. So let's see this. Let's not write this. Okay, so obviously that you can see the idea, right? So if xj is 0, then we get xy just c. If xj is 1, then we get xy as equals to 1 plus c, but c is 1 plus c is the same as 1 plus c is the same as 1 minus c. Okay. So if you choose so either you always have half probability such that these two terms will flip, right? So you can then you can use the mathematical induction, right? Because if you start with n variable, right, and you start with you only care about non-zero term, you take one non-zero term, then it will reduce to you will have half probability to have half results. Well, these always give the different results, right? Then you can pick another j such that yj is still non-zero, and then you will keep branches. Okay, but finally you ask, oh, what's the probability that xy equals to 1? But each branch is always half, right? So the answer must be half. Okay, this is somehow like the proof. You can think a little bit, but the idea is basically this. Okay, and yeah, see you guys next video.